question here says, if n is an integer and 5 to the power n is greater than 4 million, what is the least possible value of n? What is the least possible value of n? So I've done a similar question like this in the last series of videos I did on the general GRE test. So if you've not checked that, you should check that out. So I did something like this, and then what I explained in that video was that anytime you have problems like, because the thing is, you always come across problems like this in the GRE exam. So anytime you have problems like this coming up, so your aim is that what you have in the right hand side, that is the one that does not contain the power, you want to try and see if you can break it down such that it's going to contain a number that has a power of 5. Sorry, a number that has 5 as its base. That is, you want to try and break this down such that it's going to be something like a times 5 times something. So such that you're going to have 5 times something there. It's going to make the whole thing simpler. Alright, let me explain what I'm saying here. So what I have here is 4 million. I'm going to bring that down here. So what you have is, you have 4 million. So this is 4, you have 6 zeros. Now 4 million is the same thing as, so let me clear the 4 off. So you have 2 squared times, so this is 1 million. That's 1 2 3 4 5 6. Yep. So this is the same thing as 2 to the power 2 times, so this is, you have 6 zeros, so this is the same thing as 10 to the power 6. But then the thing is there a way I can obtain 5 from any of these two? You can't obtain 5 from here, it's not possible, but it's possible you obtain 10, you obtain 5 from 10. Now how do you do that? So this is the same thing as, this is 2 to the power 2 times, so 10 is the same thing as 2 times 5, now all to the power 6. So this is just the same thing as, so it's like, let's say you have 1 here. So what I'm going to be doing here is, I'm going to be using this law here that says ab to the power n is just a to the power n, a to the power n, b to the power n. So that's what I'm going to be using here. So here you have 2 to the power 2 times, now 2 to the power 1, so this 6 comes here, is like 1 times 6 like we did here. So the power spreads amongst the terms inside the bracket. So you have 2 to the power 6, then times, you have 5, then this is 6 times 1, this is 6. So this is what we have. So you observe that I've been able to obtain a 5 from here, which is very good. And then you're going to see how useful it is for me in trying to find the solution to this problem. Alright, let me first go ahead and break this down. So 2 to the power 2 times 2 to the power 6. So using the same laws of indices, is going to be 2 plus 6, which is 8, times 5 to the power 6. Yes, so now my 4 million has been broken down to this. So let's go back. Let me now write this question. Let me write it here. So what I have there is 5 to the power n is greater than 2 to the power 8 times 5 to the power 6. Yes, so this is what I want to solve. I want to solve for the least possible value of n. Now to solve for n, let me first start by dividing both sides by 5 to the power 6. I want to bring all like families together. So to bring 5 to this side, I need to divide by, I divide by 5 to the power 6, I divide by 5 to the power 6, so this goes off, and then what you have here is going to be 5 to the power, so this is division here, so I'm going to be using x to the power a divided by x to the power b is going to be x to the power a negative b, laws of indices. So this is going to be n negative 6. This is 5 to the power n negative 6, so this is greater than, now this is 2 to the power 8, so you recall 2 to the power 8 is the same thing as 256. Alright, so now we have this. So I want to find the least possible value of n that satisfies this condition, the least integer that satisfies this condition. Alright, let's go and begin to check. So when n is 1, so let me use my n here, so let's just call this n. So when n is 1, you're going to have, let's say you have 5 to the power 1. Now 5 to the power 1 is 5, right? But 5, that is when the power you have here, when it is 1, you have 5, which is less than 256. So we need the one that is greater than 256. So this doesn't work. So let's increase that. 5 2 is going to give us 25, which is also still less than 256. Now 5, so we'll just see the way the whole thing is changing. Then 5 to the power 3 is going to give us 125, which is still less than 256. But then when we have 5 to the power 4, this is going to be 125 times 5, which is 625. This is 625. Now this is greater than 256. So what this says is that the least power that has to be here, the least power of 5, such that 5 to the power, that power must be greater than 256, has to be what? It has to be 4. So that is, for 5 to the power, whatever you have here, to be greater than 256, the least number must be 4. So what it says here is n minus 6 must be equal to 4. So to solve this, you bring this here, so you have n equals 6 plus 4, which is 10. So that implies that 10 is the least positive integer such that what you have here will be greater than 256. So our answer, which is n, must be 10, and that completes the problem. Thanks for watching.